Start. Yes. Oh, good. My iPad's doing updates. Ah, yeah. Good job. Test two, done and dusted. Final exam, just around the corner. And it really is just around the corner, right? Our final exam. Is ours your first one? Probably. Yeah. I'll sneak it in here. Final exam is on December 9th from 1 to 4, I think. Oh yeah, I'll clarify. There was some confusion. So I'll take, now that you've written both your tests, I'll take your lowest test grade and shift it to the final exam if your final exam is better. Okay? And so if your final exam is better, because then I'm happy, right? We're improving and we're kind of learning, and of course that's my goal. And so if your final exam is better, then I will shift the weight of your lowest test to the final exam. Okay? And so just so you can kind of feel hopeful for the final exam, that's important, right? And like I said, my goal is that you are improving throughout the term, and so I think it's pretty reasonable. Yeah. Chapter 5. Well, any questions about that before we get into it? Okay. Chapter 5, our last chapter, and we'll see how far we get into it. But we're going to start with circles today. Trig, our only trig section. Yeah, finally trig. I know, I know. So we had worked on changing the course over the summer, and then it wasn't approved yet, and so we can't apply those changes yet. Where we would do trig first, because Frank says, "Have you guys done trig yet?" And I'm like, "Not until the very end." It's kind of crazy, actually, but so at least you've seen some trig before, and I mean, we don't have a ton of time left, so are we doing sine and cos We'll see how far we get. Yeah. It'd be great if we did it. Uh-huh. Yeah, I would give you the formulas, but it is hard to figure out what you need to use. Yeah. So here's something that we know and love. For circles, it feels weird to start with triangles, but circles are basically just triangles in a way being traced around, right? And so we start with triangles. Now, the Pythagorean theorem is on your formula sheet. It's from the very, very beginning of the course, right? And so we talked about the Pythagorean theorem, but let's do a little bit of a refresher. Okay? So if we have a right triangle, meaning we have a 90-degree angle here, then of course a squared plus b squared equals c squared, where c is the length of the hypotenuse. Mixing things up today. And so, right, if you're able to kind of translate, usually we have 2 points. If you're able to translate 2 points into a triangle, a right triangle, right, then you can find the length of any one of these 3 distances, right? Usually the hypotenuse. Right? And I'll say here, this is a 90-degree angle, just to clarify. A little square, but I'm sure you are familiar with that. So if we have to find the distance between 2 points, -5, 2 and 1, 4, for example, then I would say the first thing we're going to do is to plot those points or just sketch them out. Remember, you've got your x comma y coordinates, right? And you've got your x and your y axis. Let's clean this up here. Oh, I think I need a longer negative x axis. -5, 2, roughly. 1, 2, 3, 4, 5. 1, 2, 3, 4. Should probably go to 5. 1, 2, 3, 4, 5. Something like that. I should have made them more lofty, sorry. Nah, it's okay. Whatever. Just a quick sketch. So plotting these points, if x is -5 and y is 2, then that puts me here somewhere. -5, 2. And if x is 1 and y is 4, 1, 2, 3, 4, putting me somewhere here-ish, right? Just to sketch it out. Now, if we want to find the distance between these 2 points, right, then the distance is going to be this length here. And like I said, if we can map something into a triangle, then we can use the Pythagorean theorem. And so let's do this. How about drop down your legs? I call them legs. I don't know if that's a technical term. The legs of the triangle? I don't know. That's all right. And I'll keep it in terms of A, B, and C, of course. So then A, B, and C is the value we want to find. We've used this before, right, for finding the slope of a line, right? And so, right, rise over run looked very familiar, or very similar, I should say. And so now we want to find what A is. A is the rise, and we're rising from 2 to 4, right? And so we've got a rise of 2. And the run, we're going from -5 to +1, or if you prefer, from 1 to -5, but that's, it makes your math easier, right? 1 minus -5, but is a length of 6. But for these questions, I would say you can just eyeball it and see that it's a length of 6. Oh. So now if we have to find the distance, a squared plus b squared is equal to c squared. A squared is 2 squared plus 6 squared is equal to c squared. I'm going to go 4 plus 36 is equal to c squared. An extra step, I guess. Square root of 40 isn't anything nice, I don't think. That's okay. I'll just keep it as the root of 40 then. So C is going to be the plus minus root of 40. When you take the square root, right, you have to consider both the positive and the negative options. Now, in this case, it's not going to be a negative distance because I don't, that depends, working backwards, I guess. Going backwards is a negative distance-ish. I'd still call it a distance, but anyways, semantics. But we do have to consider both options, right, of the square root. And that's going to be even more important when we talk about circles. Because circles, if we're talking about intersections of a circle, then if you imagine a circle, imagine it there. And let's say we want to find the x-intercepts, for example, right? Then there will be two of them, right? And where they come from is going to come from the plus and the minus of the square root. And so that's why it's going to be important today. I'll remove this though, because it might be confusing later. Using a positive distance, it would be the root of 40. Nice. Now, of course, you could use the distance formula, which is also on your formula sheet already from the very beginning of the course, right? And so, but I think just kind of visualizing the points and figuring out what the distances are is, and then using the Pythagorean theorem, which the distance formula is doing, might be just as quick, but it's on your formula sheet, so you can use it if you want. So let me just, hey, turns out could not do that. All right, that's okay. So the distance formula between 2 points, x1, y1 and x2, y2, can be calculated as the square root of x2 minus x1 squared plus y2 minus y1 squared. If we use this up here, right, we would find the distance is the root of, if I let this be my 0.1 and this be my 0.2, now as long as you're consistent, it doesn't actually matter. Why doesn't it matter? Because you're going to get a negative or a positive distance, but when we square those, right, then it becomes positive anyways, so it doesn't matter. And so I use this as 0.1 and this is 0.2 typically, even though if I was clever, I would use this second point as 0.1 and the first point as 0.2 because that's how you read them. But x2 is 1 minus x1 is negative 5. Don't forget that negative. Square it plus y2 is 4 minus y1, which is 2, and then square it. So I get the distance of 1 plus 5 is 6 squared. 4 minus 2 is 2 squared, which, of course, is that same root 40. Okay, fine. I'll admit it is a little bit quicker to use the formula. Slightly, because you don't have to visualize it. So you could use whichever one you like. Building up to a circle, right? How are we building up to a circle? Well, if I have a point HK, right, as my center, right, then do you guys use those, what are they called, protractors? Yeah, those are fun, right? You have to put your point in the middle. They're not fun? That's fair. You can use a string, right? You have to fix it, use a string and go around, right? But the distance around a circle is, of course, the same all the way around. And so if you pinpoint a center, now we're going to force the center to be at HK. That sounds familiar, right, from the vertex of a graph, right? And so kind of similar but different. Context will tell you what HK is in that scenario. So for a circle, it's going to be the center of the circle. For a vertex, it'll be at the vertex, right? Of course. And so how do we build a circle? Well, I decide what the radius is going to be, right? The distance from the center to the outside of the circle. And then I hold it kind of fixed and I go all the way around the same distance. Yeah, I did pretty good. Not great. My wonky circle. Hey, that's pretty good. Don't look into it too much. It's a little bit, it's a little, that's okay. And so, but really what we have, right, is we can find this distance, which is then going to be the radius of the circle, right? And so if I force this center, HK, and I can let that be my point 1, just trying to match the formula sheet here, point 1, and then my XY can be my point 2. Right? Then we can find the distance, right? The distance is going to be R, which is going to be the square root. Wait, that's not what I wanted. I'll do the generic distance formula first. X2 minus X1 squared plus Y2 minus Y1 squared. Forcing my point 1 to be HK and my point 2 to be XY, I get X minus H squared plus Y minus K squared, and then square root that. And that's going to be R, the radius of the circle, which is a distance between 2 points. Which is so close to the equation of a circle, right? And so the equation of a circle is, okay, well, it's all these possible combinations of x, y that go around if the radius is r, right? And so we can say that, or r squared is x minus h squared plus y minus k squared. And this is going to be the equation of a circle. And all centered at HK. With a radius of R, but it's in the little block on the next page. So that's how we get it. We just need to know how to use it, right? And I'm pretty sure the equation of a circle is also on your formula sheet already. Kind of confusing because it's at the very beginning, right? Because we introduced all these concepts just briefly at the beginning, right? The equation of a circle, centered at a point HK with a radius R, can be written as x minus h squared plus y minus k squared is equal to r squared. Well, I feel like I might have jumped the gun and done this part too early. That's okay. Just draw something nice. Or how about this? How about a sticker instead? Because I already did it. Although this, it looks so mean. What if you have to, strong. How about now? That doesn't look like a mouth. I guess this is both the nose and the mouth. Anyways, we already did the equation of a circle up above. Write an equation for a circle with its center at 2, -3 and a radius of 5. So, mapping this, if the center is at HK generically and the radius is R, right? Those are all the components that we need to write the equation of a circle. And we have x minus h squared plus y minus k squared is equal to r squared. Plugging in the values that we do have. Now, the thing about circles is the x and the y are just going to be variables, right? And so we'll be able to plug in a value of x and find the value of y and vice versa, right? And so x and y are just going to be x's and y's. So we have x minus 2 squared plus y minus -3 squared is equal to 5 squared. You can simplify inside the brackets. Just make sure x minus 2 squared, I'm going to keep it as just x minus 2. I'm always tempted to expand it, right? Resist the urge. It's always a little bit easier for circles, especially if you just kind of keep them as x minus 2 squared and y minus whatever, or plus 3 squared in this case. Okay. So just a word of caution, because as soon as I see something to the power, then I'm always tempted to expand it for some reason. I don't know why, but just how I am. Y plus 3 squared is equal to 5. Well, we usually keep the terms squared and not expanded. Unless you want to solve for a y or an x, right? Then you would need to expand them. Not expanded. Well, you don't need to, but sometimes it's easier unless you want to solve for x or y. And so this is the equation of a circle. Right? We're used to seeing functions, right? F of x equals 3x squared plus 2x plus y, that kind of thing, right? Where we've kind of solved everything in terms of y, but this is an equation of a circle. Yeah? Nice. Notice that we call it an equation and not a function. Why isn't it a function? Crosses at 2 points. So it's still an equation, right? And so we can still work with it, but it's not a function. And so I'll highlight that here. Not a function. Still work with circles, of course. Right? Work with non-functions, but we lose some of the function things like finding the inverse, for example. You could find the inverse on a specific domain, right? You could restrict the domain. And the range, I guess, be hard. We don't really do that. This up here. Yes, because if you, well, sometimes they're out of the circle, right? But if your x, your circle looks like this. Yeah, I should have waited for it to steady up. Right? And if you want to let x be, I don't know, 4, doesn't matter, because I don't have a grid. Right? Let's say something like this, and I want to let x be 4, just kind of pretending that's at 4, then your solutions for y would be there, right? Assuming that it's inside the circle, right? The value of x. We'll get there. Find intersections soon enough. First, we'll write an equation for this circle. All we really need to find an equation of a circle is where is the center and where is the radius, or what is the radius. And so we need the center and the radius. I guess I jumped in and I assumed that you knew what the radius was. It's the length from the center to the outside of the circle. I'm going to eyeball it and say my center is going to be at -2, 1. And my radius looks like it's going to be, now I like to pick kind of obvious distances, right? The distance between 1 and 3 is, of course, 2. You don't want to be thrown off by it going to 3 because it's been bumped up 1, right? So you want to be a little bit careful. The radius is going to be 2. With those 2 things, we have everything we need. X minus h squared plus y minus k squared is equal to r squared. X is just x. X minus -2 squared plus y minus 1 squared is equal to 2 squared. Simplifying inside the brackets, but nothing more than that. And the 2 squared maybe might be nice. X plus 2 squared plus y minus 1 squared is equal to 4. Ta-da! Neat. Any questions? Now we're going to do it. Find the y-intercepts. What are the y-intercepts? Y-intercepts are on the y-axis, so that's when x is equal to 0. Of x plus 1 squared plus y minus 2 squared is equal to 9. We can draw this. It doesn't ask us to draw it, right? But what we can do, we'll solve it first and then we'll sketch it out and just confirm, right? But you can find the center, right? Given the equation, you can work backwards and find the center and the radius, right? And then you can sketch the circle. But we want to find the y-intercepts. And so the y-intercept is when x is 0. And so I'm going to force x to be 0 and solve for y. And if you visualize a circle, then you know that it'll cross the y-axis probably at 2 points. So here we go. Let x equal 0, and we want to solve for y. We have x plus 1 squared plus y minus 2 squared is equal to 9. 0 plus 1 squared plus y minus 2 squared. My squares are looking not very good tonight. Still no good. 1 squared is 1, that's nice. 1 plus y minus 2 squared is equal to 9. Solving for y, I get y minus 2 squared is equal to 8. When I take the square root, right, it's going to be really important that you have the plus and the minus. Otherwise, you're only going to get, okay. Please stay on the line. It's this room. It always wants to do an update, I guess. I'll check back in. Take the square root. Y minus 2 is the plus minus root of 8. And then add 2 to both sides. Y is, now what I'm going to do, because the plus minus kind of looks nicer if it's on the right-hand side. Now, of course, you're more than welcome to say plus minus root 8 plus 2, but just be careful when you write it. So you can write it like this, but then you want to be really, really obvious that the root ends here, right? And so I use these little hooks to emphasize that that's the end of the root, right? And then plus 2, but I prefer to write y equals 2 plus minus the root of 8, just so that there's no confusion. Sometimes I get lazy and I just tack it on at the end, but and it reads nicer too, right? 2 plus minus root of 8. Let's see if this, share my screen. It's still recording, so that's crazy, but whatever. Okay. Think we're back in business. I will say or, right? The 2 on that side, which is kind of my preference. 2 plus minus root of 8 is kind of hard to imagine, right? And so I'll give myself a little bit more room here. Maybe not. It doesn't want to. I'll do them individually. So approximately y is, and I'll do the 2 minus the root of 8. Approximately, the decimal version. 2 minus the root of 8 is roughly negative 0.828427, blah, blah, blah. And y is roughly 2 plus the root of 8, 4.828427, blah, blah, blah. We can sketch this out to make sure that that answer makes sense. And so from the equation of our circle, this thing is centered at HK, right? And so if we map this back, x plus 1, so x minus h is equal to x plus 1, which means that h must be at -1. And k, then y minus k must be 2. And r must be 3. So it's centered, oops, clarify here. -1, 2. And so if we kind of sketch this out, -1, 2, centered at -1, 2, with a radius of 3. I'm going to go up 3 here. 1, 2, 3. Oops. It's a little off center, isn't it? Pick a point, distance of 3 away, and then draw it, which is not my strong suit. Something like that. Oh. I didn't do a very good job, did I? Why? My y-intercepts should be at 4.82-ish. At least it's above 4. And right, 2, 3, 4, and below 5. So this one's pretty good. I didn't do a very good job on my lower axis though, because this should be at -0.82, blah, blah, blah. So here, this is at 0, 4.828-ish. And this point here is at 0, -0.828-ish. My rough sketch. And my even rougher looking circle. That's okay. Nice. You can use Desmos to check it too. Nice. So we can find intersections, right, of a circle as well. So much chatter up there. It's an exciting. So on the unit circle, which implies that we know what the unit circle is, but just as a refresher, a unit circle is a special circle. Say about it, no. The unit circle is a circle centered at 0, 0 with a radius of 1. And so it's centered at 0, 0, 1, 0, 0 with a radius of 1. Which means that the equation x minus h squared plus y minus k squared is equal to r squared for the unit circle is the equation of a circle that we're probably most familiar with, right? X squared plus y squared is equal to r squared, right? But that's forcing it to be centered at 0, 0. Bless you. So x minus 0 squared plus y minus 0 squared is equal to 1 squared, which is how we get the x squared plus y squared is equal to 1. So on the unit circle, we want to find x when y is equal to 1/2. Well, plug in y equals 1/2, right? And solve for x, remembering that you're going to get two values, right? The unit circle is a little bit easier to draw because it's centered. Well, if I 0, 0, which means that this distance is going to be 1, -1, 1, and -1. Pretend that's true. It's kind of a wonky circle. So the radius is 1 all the time. Now, when y is equal to 1/2, let's use this here, then let's say here y is equal to 1/2. I'm expecting to find 2 points on the circle. In fact, I want to find these two values of x. Map them down. X and x, x1 and x2 or something like that. So how we do that, right? You just plug in y equals 1/2 and solve for x. So x squared plus 1/2 squared is equal to 1. 1/2 squared .25 x squared plus 0.25 is equal to 1. So I get x squared is the plus, nope, not yet. Is 1 minus 0.25, so 0.75. Now x is plus minus the root of 0.75. So if I take the root of 0.75, oops. I wish I had, just to keep it on the same page here. X is roughly 0.866 for the negative 0.866. Because it's centered at the origin at 0, 0, right? Then, of course, I expect these distances to be the same from 0, 0 on either side. Whereas if you've shifted your circle around, then they won't have that symmetry anymore. They'll still be the same distance, but it's harder to think about. Nice part about visualizing it first is you can kind of talk yourself into, do these answers make sense, right? And so negative 0.866 and 0.866 looks good, right? Because I'm expecting it to be within -1 and 1, and that's really my only check-in point. But also from my rough sketch, those look like reasonable answers. Nice. Any questions about the one? If you have to find the intersection of x squared plus y squared equals 16 and f of x is equal to 3 minus x. So now you have a circle with a radius of 4, right, centered at 0, 0. Just from the equation of the circle, now we know that that's what it looks like, right? And a line, right? A line with a y-intercept of 3 and a slope of -1. Right? And so we know how to draw both of these things, and so you could sketch them out, right? And it might be nice to have just to visualize it. So here, right, what we know is that it's centered at 0, 0, and the square root of 16, I know the radius is 4. For my circle, and I know that this is a line with a y-intercept at y equals 3 and slope equal to -1. Well, I'm going to go for it, and just to keep it on the same graph, I'll say here's 1, 2, 3, 4. So on. So there's my circle. I almost think that circles are easier to graph than lines sometimes, which is weird. But the y-intercept is at y equals 3 for this thing. And so I know here's a point. If I let x be 0, then y should be 3. All I need is another point. I like to pick a value of x that I have kind of sketched out, no matter how rough my sketch is, right? And so if I force my, well, should I be sneaky about it, my x to be 3, right, then I'll force my y to be 0, and that might be nice to graph. Right? You can pick any value of x, but I will pick the convenient value of x equals 3, so I can graph this thing. Connect the lines, need a straight edge. Here's the edge of my calculator here. So what we're solving for are these 2 points, right, where those equations have the same coordinates. And we'll find 2 points because it's a circle. Right? The only time that you would only find 1 point is if it's exactly tangent, which can happen. So I'll point that out, but usually we'll be finding 2 points. I'll remove that. Okay, we know how to find the intersection of 2 lines, right? What do? You set them equal to each other, right? That's one way to do them, right? But really, what are you doing? You're kind of substituting one of the equations into the other one. Huh? And so if we remember that f of x is really just y, right, then I can substitute y equals 3 minus x into my circle, which is probably the easiest way to go, right? You could solve for x or y in the circle and then substitute it into the line, but I think that's more complicated, and so I would advise against that. But what we can do is we can substitute y equals 3 minus x into the circle. I'll say the equation of the circle. Because at these points, y equals 3 minus x has to have the same output as x squared plus y squared equals 16. So x squared plus y squared is equal to 16. And if I substitute 3 minus x in for my y, then I get x squared plus 3 minus x squared is equal to 16. Now I have x's, right? Just x's in here as my variable, which is really nice. And what's exciting too is I feel a quadratic coming on, which we know how to work with, right? And what's nice about quadratics is we know that we get two solutions, right? The plus and the minus. So we're feeling good. All right. Now, this is where we have to expand it in order to get that quadratic, right? So here we go. So now solve for x. So I get x squared plus, and I always have to write out my 3 minus x times 3 minus x. So I always expand it really nice and slowly. And I know that some of you guys are really quick at expanding it. I got all those tricks up your sleeves, but I do it nice and slow. And it's got me this far, so why not? So we get x squared plus, and then 3 times 3 is 9. And I'm going to keep my brackets just in case there's a negative inside, right? Because I don't want to forget, or especially if this was minus, which it's not, but just be careful. So 3 times 3 is 9. 3 minus 3x minus 3x plus x squared is equal to 16. Negative 3x minus 3x 6x plus x squared is equal to 16. Rearranging these and collecting my like terms of x squared, I get 2x squared minus 6x plus 9 is equal to 16. A polynomial where the highest degree is 2. This is a quadratic, which we already sensed was coming, right? But here it is. I'll do a smiley face instead. We love quadratics. Have you guys figured out how to solve quadratics on your calculator yet? Can't remember how you did it. One of these, it solves quadratics, and I should have remembered. Base and matrix, no. I think it's in the equation slash function. Let me try it. 2 polynomial, degree 2. Okay. Yeah, it's in there. You still have to give it what your A, B, and C are, which means it has to be equal to 0. So to use the quadratic formula, right, then we have to force it to be equal to 0 by moving that 16 over. So we get 2x squared minus 6x plus 9 minus, oops, I'm in the wrong mode now. 9 minus 16, negative 7 is equal to 0. So now we can use the quadratic formula. Or explore, or use the calculator function, which you're allowed to use on the final exam, as long as you tell me, using the calculator, I found these two values. Okay? And so you don't have to do it by hand. I'm going to, because it's tried and true, but as long as you tell me where you got those values from, right, using my calculator, that is totally fine. negative b plus minus the square root of b squared minus 4ac divided by 2a. I get negative 6 plus minus the square root of negative 6 squared minus 4 times 2 times negative 7 by 2 times 2. Let's see here. 6 plus minus the root of, let's see here, 36 minus 4 times 2 times negative 7, the root of 92. I want to confirm that that's what you guys got, maybe. And don't forget, divide by 4. Now, the root of 92 is nothing nice. Nope. Here's hoping. It's always worth checking. But we do get an approximation, right? X is approximately, I'll do 6 minus the root of 92. 6 minus the root of 92 divided by 4, which is roughly negative 0.8979. 2. And then 6 plus the root of 92 divided by 4, 3.8979. Rounding a little bit. Do these values look reasonable, right, from our sketch, right? Negative 0.9, let's call it. So X is at negative 0.9. Now from my sketch, that looks like could be a reasonable answer, right? And the next one, my X is 3.9-ish. 3.9, right? It'll be just on the inside curve of the outside of the circle, which would be 4. Well, it's still on the circle, but this is at 4. But then if you imagine the circle, it's come down just a little bit to X equals 3.9. Now the intersection is at an XY coordinate, which means we're not quite done yet, because I also need to solve for y. Now, you can use whichever formula or equation you'd like, right? X squared plus y squared is equal to 16, and you can force your x to be the two values of x that we found, right, individually. I would probably prefer to use the y equals 3 minus x, just because it's a little bit easier to work with, right? But you should find the same answer regardless of which equation you use. Just one's a little bit more work. But because it's the intersection, they'll give you the same answer. So now, solve for y at each point of x. And I want to keep it on this page. So using y equals 3 minus x, I get negative 0.89792. If I let x be negative 0.89792, 3 minus negative 0.89792. Oops. I threw in another bracket. I get y value of 3.89792 And if x is 3.89792, y is going to be 3 minus that, 3 minus 3.89792. Nice. Yeah, is it, I should have brought my new snazzy calculator. Do you have your calculator? Do you mind if I... Oh, snazzy. Do you mind if I show this? Okay. Do this. My go-to. We don't have document cameras anymore, but sometimes we should. On your calculator. Let's see if I can pull this off. Mode. Vibe, so equation. You want the quadratic, which is the third option. And do you remember what the numbers were? 2, -6. This is kind of difficult. -7. I saw a nod back there. And equals 3 plus 20, the root of 23 over 2. I'll zoom in. All artsy here. And then if you hit equals again, x value minimum. Wow, fancy. Y value for the minimum, which tells you it's a quadratic facing up, right? Which is all things that we know. And so I encourage you to try it. And I think, yeah, you can hit this and get the decimal version. Da, 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 da. Phew, we did it right too. Feels good. Anyways, thank you. So you're allowed to use your calculator functions, which means might be worth practicing for the final exam. I know, where was that when you were finding the vertices and things like that? It's been there this whole time. All right. Nice. Okay. Any questions about that one? I feel like we finished it. You can confirm, right? You want to make sure that your y can't be bigger than 4, right? Because that would be outside of the circle, and then so something happened, right? But we found it was roughly 3.9 and negative 0.9-ish. All of those seem to make sense. Nice. What am I doing for time? All right. I think this next question is my favorite question in the entire course because it's kind of cute, but it also incorporates a lot of things that we've learned into one question. And so it's kind of fun. All right. An ant is heading toward a circular region of pancake batter. The ant cannot breathe while walking through the batter. The batter has a radius of 4 centimeters. Feels like kind of a big spill. This, a full pancake sort. The ant is going to walk from a point 6 centimeters due north of the batter's center to a point 5 centimeters due west of the batter's center. If the ant moves at 0.8 centimeters per second, how long will it have to hold its breath? Okay. Lots of components here. We have a circle, right? We've got our batter, right? And so we've got a circle and an ant that's walking. I'll just do a quick sketch here. And don't worry, we have our ant lined up, ready to go, because I think it's so cute. So we've got this pancake batter and 6 centimeters due north to west. So it's going to be walking something like this. Right? Which means that the ant has to hold its breath for this distance, which we also know how to find, right? The distance between 2 points. But how do we get the 2 points kind of working backwards? Well, the points that I'm working with are the intersections of these two equations, right? And so I have the equation of a circle that I can create. I have an equation of a line that I know how to make, right? And I know how to find the intersections of two things, right? Two equations. And I know how to find the distance between 2 points once I have them. And so, like I said, it incorporates a lot of components, things that we have learned. So let's sketch this thing out. I've given a grid, right? I've given myself a grid, I guess. And one kind of leap that we're going to make is that I'm just going to center the batter at the origin, right? That's something we're allowed to do. So because everything is in reference to the batter's center, right, I may as well put it at the origin. Right? Okay. The batter has a radius of 4 centimeters. So let's start there. I've got 1, 2, 3, 4 here. 1, 2, 3, 4. 1, 2, 3, 4. See if I can 1, 2, 3, 4. 1, 2, 3, 4. Let's see if I can catch all these. Might be hard. Not bad. So there's our pancake batter, right? Forcing the center to be at the origin. Now, do you guys work with coordinates? Never eat shredded wheat or something like that? What are, there are some other ones, right? Never eat shredded wheat. Something like that. They're usually never eat something. But the ant is going to walk from a point 6 centimeters due north, which just means north of the center. And so from 6 centimeters, 1, 2, 3, 4, 5, 6, using my grid in centimeters. So this is 6 centimeters due north. Of the batter's center to a point 5 centimeters due west, which puts me here. Now, hopefully, I think I have to make my circle a little bit better there. So if I connect those 2 points, right, and now I know that my ant started over here. Wait, hey. No. My ant. The cutest little ant. How do I bring it forward? There. And they're walking down towards the batter. Right? So it's not much, but it will intersect the circle, right? And so we want to find here and here. Specifically, in order to find this distance here, where it has to hold its breath. Okay. Do ants breathe? Probably. I mean, David Lippman wouldn't make up a question like this without doing the research, right? He's kind of a famous guy.
You know, but they're actually in the pancake. It would just make more sense to go around.
I hope that they would be smart enough to just go around. But in this scenario, they're not. They're just an ant. All right. Sketching out the problem is obviously kind of among the hardest parts, but also kind of mapping out how you're going to solve it, right? That's difficult as well and takes some practice. Okay? So we want to find this distance. But in order to get there, right, we need to find these 2 intersections. But in order to find the intersections, I need equations for the circle and for the line. So kind of mapping backwards. And I'll add a page here. We want to find the distance between the intersections. Between the intersections. Which means we need the points of the intersections. We need the points of the intersections. But to get the points, we need the equations of the circle and the line. We need the equations for the circle and the line. So that's where we'll start. Right? Once I have those and I feel like I have a lot of the components that I would need in order to find those equations. And so that's where I'm going to start. So find the equation, let's say of the circle first. Any circle x minus h squared plus y minus k squared is equal to r squared. Now we force the center to be at 0, 0, which was kind of a smooth move, right? Because that makes our equation of the circle a little bit easier. And so let hk be 0, 0. Then I get x squared plus y squared is equal to r squared. Now we were told the radius is 4 centimeters, but we dropped the units. So 4 squared, or 16. So x squared plus y squared is equal to 16. Nice. Now I need the equation of my line, which we also did. All right, chapter 1, chapter 2, we found equations of lines, and so we know how to do that. What do you need first? You need to find the slope of the line. All right. So now we're going to find the equation of the line. We have y equals mx plus b. M is y2 minus y1 over x2 minus x1. Now I'm going to use the points that we were given in the question, right? Those are my only 2 points that I really know, right? And so here, this is at 0, 6, and this is at negative 5, 0. Right? Of the line between zero, 6 and negative 5, 0. Let me just make sure that's what I wrote. All right. Find the equation of a line between 2 points. You know how to do that. All right, that's test 1 stuff. And so, let's see here. 0 minus 6, negative 5 minus 0. I get a slope of negative 6 over negative 5, which makes sense because I have a positive slope, right? And so those negatives over negative are going to make a positive. 6 over 5 is just 1.2. You're welcome to keep using the fraction, but it might get a little bit overwhelming, and so I would try the decimal and if it doesn't even, so this rounded nicely, it is just 1.2. If it doesn't round nicely, then you're allowed to round to, let's say, 2 or 3 decimal places. I know, vague. 2 or 3. Maybe I'll move this down 1. Find the slope. And now find the y-intercept. It's the only one in our equation. And use either one of those points. All right, xy coordinates and your m that you just found. And I'll use the first point here because I don't like negatives. 0, 6 means that from y equals mx plus b, I get 6 is 1.2 times 0 plus b. Which makes sense, right? Because we can see from our sketch that the y-intercept should be 6. So therefore, y equals 1.2x plus 6. There's the equation up the line. So now I have my equation of a circle, and yeah, I think it's interesting that finding the equation of a circle tends to be a lot easier than finding the equation of a line, right? Not easier, but quicker, I guess. But both things that you know how to do. Now we want to find the intersection of these two things, but this just turned into the exact same question that we just solved, right? And so we already know how to solve this now that I have an equation for the circle and an equation for the line. So we can find the intersection of x squared plus y squared is equal to 16 and y equals 1.2x plus 6. We use the same maneuver, right, where I am going to plug in y equals 1.2x plus 6 into my circle and solve for my x's, right? So x squared plus y squared is equal to 16. X squared plus 1.2x plus 6 squared is equal to 16. Oh. Try not to move the wrong things. There. I want to have my equal sign stacked. Okay. Now I'm going to expand this thing because my ultimate goal is to find my x, right? And again, I can feel a quadratic coming on, right? Which makes sense. So x squared plus 1.2x plus 6 times 1.2x plus 6 is equal to 16. 1.2 times 1.2 puts me at 1.44x squared. And then 1.2 times 6, hey, plus 7.2x plus 7.2x plus 36 is equal to 16. Seven 7.2 plus 7.2 puts me at 14.4. I have only pluses, and because I have a plus here, right, I can remove the brackets. But I like to play it safe. X squared plus 1.44x squared plus 14.4x plus 36, and I'm going to also move the 16 over right away and set it equal to 0 in the same maneuver while I'm simplifying things, because I need it to be equal to 0 in order to use the quadratic formula. So now I have 2.44x squared plus 14.4x, and 36 minus 16 is 20, 0. Now I encourage you to try the calculator way, right? I'll do it old school, by hand, if you will. But this, I can use the quadratic formula again. X is negative b plus minus the square root of b squared minus 4ac divided by 2a. Negative 14.4 plus minus the square root of 14.4 squared minus 4 times 2.44 times 20. Something tells me that's not going to be a nice root, but that's okay. Divided by 2 times 2.44. Let's see. 14.4 squared minus 4 times 2.44 times 20. Negative 14.4 plus minus the root, I get 12.16. 2 times 2.44 divided by 4.88. All right. Negative 14.4. I'll do the minus first for consistency. Minus the root of 12.16, then divided by 4.88. I get negative 3.6654, let's say. And negative 14.4 plus the root of 12.16 divided by 4.88. Negative 2.2362, keeping 4 decimal places. Do these values make sense? Right, they're both negative. So in the negative x quadrant, quadrant 2, if you're familiar, looks good, right? Slightly past negative 2 and just before negative 4. And so what I've found kind of checks out with what I drew, right? So that's nice. And what I'm going to do here is copy this. So what we found, oops. Is this value and this value. Negative 2.24, let's say, rounding a lot, 3.67. Those both look reasonable, right? But I need the points, right? Which means I need to find the y values, right? I need to find this value and this value. Now you can use the circle if you want, but it's harder, right? I prefer to use the line. It doesn't matter. They should give you the same value because it's the intersection, right? And so now find the y coordinates. So cute. Did she just say, I love my dad? That's so adorable. Find the y coordinates. I'll say using the line, using y equals, what did we say it was? 1.2x plus 6. You can try it with the circle. Maybe it's nicer. Or x squared plus y squared is equal to 16. Right? You've got values for x. Right? Plug in the x and solve for the y. What you would find, assuming that you haven't done any rounding, right? And so as long as you haven't done any rounding, they should give you the exact same answer. If you've done some rounding, then there'll be some wiggle room, and that they're not going to be exactly the same. I'm going to use the line, 'cause I'm lazy. Y is 1.2x plus 6. Y is 1.2 times, so now I've used the rounded value, that's okay. Negative 3.6654 plus 6. .6654 plus 6. I get a y of 1.60152, which, if I trace back from this x coordinate, then 1.6 looks reasonable. All right. You always want to make sure that your answers are reasonable. 1.60152-ish. And for the next one, I'll do them side by side. It's 1.2x plus 6. 1.2 times negative 2.2362 plus 6. 2 times negative 2.2362. 6. I get 3.31656, which again looks pretty good. 1, 2, 3. Yep. 3.31656. Which means that our intersections are at negative 2.2362 and 3.31656 and negative 3.6654, 1.60152. Now I just have 2 points and I want to find the distance. We're so close. So find the distance between the 2 points. You can use the distance formula. Might be nice in this case, right? Otherwise you have to find the rise and the run, and just kind of is a little bit messy, right? And so the distance formula, I'll grab it from way back here. Between 2 points. Because it's on your formula sheet, you may as well. Just be careful with all the decimal places. I probably should have rounded a little bit harder, but it's hard for me. I'll use this as my 0.1. And this is my 0.2. But it doesn't matter, right, since we square. Negative 3.6654 minus negative 2.323. Nice try, Emily. 0.2362 squared plus y2 1.60152 minus 3.31656 squared. Yeah. Thank you. that one, right? Yeah. Nice. Okay. Let's see here. -3.6654 plus 2.2362. I get the -1.4292 squared plus 1.605152 minus 3.31656. -1.71504 squared. Square that. 4, 6-ish. 1, 2. I am rounding in here. That's okay. Nope, I already did the square. I get a distance of 2.2325 centimeters. Finally. But the question was, how long does he have to hold his breath? Yeah. A distance of 2.2325 centimeters at a speed. Well, where is it? Of 0.8 centimeters per second. All right. Uh-oh. Those, not really unit conversions. But I know you do. Do you do a lot of cancellations in chemistry and physics, probably? So you guys are good at it. All right. If you've walked 2.2325 centimeters per second, now how long at 0.8 centimeters per second? The distance, or let's just go for it. 2.2325 centimeters. I'm going to divide by 0.8 centimeters per second, because that's going to be 1 second per centimeter. Times 1 second per 0.8 centimeters. Now I'm able to cancel my centimeters, and I get 2.325 divided by 0.8, and I get 2.90625 seconds.
2.2325. You missed it.
Ooh, sorry. Nice catch. Do I have to do it in red? Can I just, it was so. I kept wanting to not write that. 2.2325. Now let's try it. All right. How about 2.790625 seconds? Sold. Roughly 2.8 seconds. Almost 3 seconds. Nice. How'd we do? Pretty good. The next one? Everyone wants to solve the next one on their own. How about? Let me just make sure. Okay. We don't have time to do this one, but I do want you to try the next one. Yeah? And so I can dig it up. How about when I'll post the answer in the notes when I post them, before I post them, and then we'll use it for review on Thursday. But try it. And so, how much of Meridian Road do they deliver to? It's a pizza delivery situation. So you can try it, and then we'll use it for review on Thursday. If you have any questions, let me know. Otherwise, see you then.
Oh,